Let's continue with the back page of the derivatives limits FRQ worksheet. So number 3, consider the equation x squared minus 2xy plus 4y squared is equal to 64. That's an equal sign here. Part A, write the expression for the slope of the curve at any point xy. So it's essentially asking for the derivative function or derivative equation. But this is not going to be a function. Notice that your x and y's are mixed together. So if we want to find the derivative equation, we have to involve implicit differentiation. So remember, again, the steps for implicit differentiation is each time we come across the derivative involving y, we have to attach a dy dx. Okay. So we're going to treat each like a separate term and just apply the derivative rules for each. So x squared is, we can apply power rule, so that's 2x. Now we got to be careful here. 2xy, these are two separate variables that are being related to one another by multiplication. So that means we have to apply product rule if we want to find the derivative involving x and y multiplied together. So product rule is f prime g plus fg prime. So I'm going to apply product rule. I'm going to factor out pull the negative outside and then distribute it through later. So I'll treat I'll treat the 2x as the first term and then the y as the second term. So product rule says f prime g plus fg prime. So f prime, the derivative for 2x becomes 2. The derivative, so f prime times g, so the original g function is y, so f prime g, that's the first part of the product rule, plus f, so that's 2x, times g prime. So g prime is the derivative for y, so the derivative for y is 1, but because we're involving y's derivative, we're going to attach a dy dx. All right, plus, all right, 4y squared, the derivative for 4y squared is 8y. But then again, we're now still involving y's derivative, so we have to attach dy dx. Equals, all right, the derivative for 64 is 0, so careful. This 64 is also being affected by the derivative rule, so we don't want this to remain 64. That 64 is going to turn into a 0. All right, constant goes to 0. All right, so now it's just a matter of cleaning up and trying to isolate dy dx by itself. So here, there's a negative out here. I'm going to distribute the negative through. So minus 2y minus 2x dy dx plus 8y dy dx equals 0. I can begin to group the terms with dy dx on, together on the left side. The 2x and 2y, I'll move over to the other side, but making sure to change signs for those. So negative 2y becomes positive 2y, 2x becomes negative 2x. Factor out the dy dx. We're left with negative 2x plus 8y. Divide to the other side. So I'm left with 2y minus 2x over negative 2x plus 8y. I can factor a 2 from each of the terms. And I'm left with y minus x over negative x plus 4y. So here's the answer. This is a free response, so this is completely acceptable. However, if this is multiple choice, you may see something like this where the answer choice could have a negative 1 distributed to both the numerator and denominator. So we could also write this answer as if I multiply everything through by negative 1, I'll get negative x will turn to x, y will turn into negative y, negative x will turn into x, and 4y will turn into negative 4y. Okay, so both answers are correct. I want to point this out to you in case this is a multiple choice question on an AP exam. If you're here and the answer choice is here, you need to be able to make the adjustment and see that these are the same answers. Okay. All right, part B. Find the equation of the tangent line to the curve. So if we want to find the tangent equation of the tangent line, we first need to, well, here's tangent line equation. Tangent line equation, we need a point and we need a slope. All right. So we need point, ordered pair, and we need the slope. All right. So ordered pair, we have the x value. What's missing is now the y value. So if we want to find the y value, we're going to take this x value 2 and plug it back into the original equation and see if we can find the y value. So if I replace every x with 2, then I can solve for y. So 4 minus 4y plus 4y squared is equal to 64. I can factor out a 4, or actually bring 64 over to one side, and then I'm left with this equation. Factor out a 4, I'm left with y squared minus y minus 15. And notice that this doesn't factor, so we have to go through quadratic formula. Negative b plus or minus root b squared minus 4ac all over 2a. And notice the best we can do is leave it in this form or use our calculator to find the y values here. There's two potential y values, one at 2, 4.41, and the other at 2, negative 3.41. Now, at these ordered pairs, we're going to find the slope. So what that tells us is that there's actually going to be two tangent line equations at x equals 2. So our derivative equation is either one, y minus x over negative x plus 4y, or x minus y over x minus 4y. Now, we have ordered pairs. Next step is we need the slope. So to find the slope, we're going to take our ordered pairs, plug into the derivative equation to find the slope. So if I plug 4.41 into the derivative equation, my first order pair into the derivative equation, I get 0.15. That's my slope. There's my ordered pair. There's my slope. And then I can write my point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. All right. Same thing for the second order pair. We can plug into the derivative equation. Okay, the y minus x over negative x plus 4y. Replace every x with 2. Replace every y with negative 3.41. And we clean this up. We get 0.35. So now we have our slope. We have our ordered pair. And we plug into point slope. Y minus y sub 1 equals m times x minus x sub 1.